Hello students, welcome to Marine Engineering Tutorials. I'm Atul Kumar Gupta and I'm back with a new tutorial. Currently we are studying marine boilers. In this lecture, we will first learn about the requirements for construction of boilers. Next we will study boiler plates specifications. Then we will learn about the boiler tubes and pipe sizes with their specifications. Next, we will study about the boiler tube thickness as per their pressure ratings. Then we will explore about the boiler tubes specifications. Finally, we will study the forms of steel required for various pressure parts. Let us now go through each of these topics one by one in the following slides. Requirements for construction of boilers. Quality of boiler steels. Boilers use low carbon steels of high quality and good weldability as per the temperature requirement. Manufacture and testing of boiler steel. Boiler steels are manufactured and tested to the specified codes and should be procured only from approved manufacturers. Thus, all the pressure parts materials in the boiler must come from fully recognized sources and meet minimum quality standards. Machinery and methods for construction of boilers. The machines, work procedures, inspection stages, and even the workmen, such as welders, must be individually qualified. Test certificates of pressure part materials. Boiler pressure part materials are provided with material test certificates which are further certified by an independent third party agency to confirm the reliability of the reports supplied by the manufacturers. Boiler plates specifications. Boilers require a variety of steels ranging from low strength, low carbon steels to high strength, high alloy steels and even stainless steel for different parts. The mean metal temperature range of 450 to 480 degrees Celsius serves as the general dividing line between carbon steels and alloy steels. Carbon steels. Low carbon steels with carbon between 0.2 to 0.35% has average yield strength of 242 meganewton per meter square at an average temperature of 510 degrees Celsius. It provides good ductility, weldability and permeability. Medium carbon steel with carbon content of 0.6 to 1% offers a good combination of strength and ductility. It is responsive to heat treatment and provides moderate weldability. Low alloy steels. Low alloy steels with 0.25% carbon, 1.25% manganese and 0.5% molybdenum provide yield strength of 350 meganewton per meter square at maximum temperature of 538 degrees Celsius. They provide good strength and creep resistance at elevated temperatures. Medium alloy steels. Medium alloy steels with 0.17% carbon, 1.25% manganese, and 1% molybdenum provide yield strength of 315 meganewton per meter square at maximum temperature of 577 degrees Celsius. They provide improved creep strength and oxidation resistance suitable for higher steam temperatures. High alloy steels. High alloy steels with 0.17% carbon containing nickel, copper, molybdenum, and vanadium provide yield strength of 420 meganewton per meter square at maximum temperature of 500 degrees Celsius. They provide very high strength and toughness, excellent resistance to creep and fatigue where high stresses are encountered. 304 stainless steel. 304 stainless steel with 18% chromium and 8% nickel is a versatile and widely used grade. Has average yield strength of 225 meganewton per meter square at maximum temperature of 870 degrees Celsius. They provide excellent formability, corrosion and oxidation resistance in superheaters. 316 stainless steel. 316 stainless steel with 17% chromium, 12% nickel, and 3% molybdenum is known for its enhanced corrosion resistance, especially in more aggressive environment, and provides average yield strength of 225 meganewton per meter square at maximum temperature of 925 degrees Celsius. 321 stainless steel. 321 stainless steel with 18% chromium and 12% nickel is similar to 304 grade, but with the addition of titanium, which stabilizes the material against chromium carbide precipitation, has average yield strength of 225 meganewton per meter square at maximum temperature of 900 degrees Celsius. They provide resistance to intergranular corrosion and carbide precipitation and are preferred for prolonged service at elevated temperatures. Chromium, molybdenum, manganese, and vanadium are used to increase creep resistance. 9% chromium, 1% molybdenum, vanadium steel has been found to be very successful, leading to a significant reduction in the use of stainless steel. The limiting temperature and the required strength are the main factors that determine the appropriate metallurgy. Boiler tube pipe sizes and their specifications. Boiler tubes come in a range of diameters and thicknesses to meet different design and operational needs. Common sizes for boiler tubes are typically specified in terms of outer diameter and wall thickness. Boiler tubes may be specified by following particulars. Nominal pipe size. As per British system, boiler tubes are specified using the nominal pipe size, which is a standardized designation that does not necessarily reflect the actual dimensions. Common LPS sizes for boiler tubes include 1 inch, 1.25 inch, 1.5 inch, 2 inch, 2.5 inch, 3 inch, 4 inch, 5 inch, 6 inch, and larger. Nominal tube size as per metric system. As per US system, metric dimensions are used for specifying boiler tubes. Metric sizes are specified in millimeters and common metric dimensions include 25 mm, 32 mm, 40 mm, 50 mm, 65 mm, 80 mm, 100 mm, 125 mm, 150 mm and larger. Outside diameter. Whether following British or American system, boiler tubes have standard outside diameter depending on the application. Common outside diameter sizes are 34 mm, 42 mm, 48 mm, 60 mm, 76 mm, 89 mm, 114 mm, 140 mm, 169 mm and larger. Wall thickness in millimeter corresponding to standard wire gauge number. The wall thickness of boiler tubes is an essential parameter for ensuring strength and durability. Wall thickness can vary widely, which can be specified by standard wire gauge as per British system or on schedule number as per US system. Some standards wall thicknesses for boiler tube as per the British system corresponding to standard wire gauge 0 to 10 are specified here. Length. Boiler tubes are typically available in standard length of 20 feet, that is 6.1 meters. Although manufacturers can supply custom lengths to suit specific boiler design. Classification of steam pipes. Steam pipes are classified in following three categories. Class 1 steam pipes are used for high pressure steam application for pressure above 15 bar and temperature above 220 degree Celsius. Class 2 steam pipes are used for medium pressure steam applications for pressure between 7 bar to 15 bar and temperature ranging from 150 degree Celsius to 220 degree Celsius. Class 3 steam pipes are used for low pressure steam applications for pressures between 0.7 bar to 7 bar and temperatures ranging from 100 degree Celsius to 150 degree Celsius. Boiler tube thickness as per pressure rating. Schedule number. Pipe schedule is a standard method used to define the wall thickness of pipes. It is a dimensionless number based on the ratio of pipe's nominal pipe size to wall thickness. The schedule number is important because it determines the pipe's pressure carrying capacity. Various available pipe schedules are shown here, but Schedule 40, 80 and 160 are commonly used on ships. Thickness T of the tube. The thickness T is calculated using the formula T is equal to P into D divided by 2 into S into 1000, where P is the boiler design pressure, D is the outside diameter and S is the allowable stress for the material at operating temperature. Finding tube wall thickness from the table. Tube wall thickness can be found from the table of schedules. For example, a 50 or 2-inch nominal board pipe with its outside diameter at 60 has wall thickness of 4.0 for schedule 40, 5.5 for schedule 80 and 9.5 for schedule 160, which can withstand pressures of approximately 70 bar, 99 bar and 155 bar respectively. Corresponding standard wire gauge number are also stated against thickness for various schedules used. Schedule 40 is one of the most common schedules suitable for general pressure applications with moderate pressure. Schedule 80 is used for applications requiring thicker walls and higher pressures. Boiler Schedule 160 is used for high pressure and high temperature boiler and hydraulic applications. Specifications. The material used for boiler tubes must be capable of withstanding high pressure, high temperature, thermal cycling, corrosion, and erosion while maintaining adequate strength and ductility. The choice of material depends on the operating pressure and steam temperature of the boiler. Carbon steels. Low tensile steel. Low tensile steel with carbon less than 0.8% has average yield strength of 179 meganewton per meter square at an average temperature of 510 degrees Celsius, provides good ductility, weldability and permeability. Medium tensile steel. Medium tensile steel with carbon less than 0.27% has average yield strength of 255 meganewton per meter square at an average temperature of 510 degrees Celsius and offers a good combination of strength and ductility. It is responsive to heat treatment and provides moderate weldability. High tensile steel. High tensile steel with carbon less than 0.35% has average yield strength of 276 meganewton per meter square at an average temperature of 510 degrees Celsius and offers a good combination of strength and adequate ductility. It is responsive to heat treatment and provides moderate weldability. Low alloy steels. Low alloy steel with 0.5% molybdenum has average yield strength of 207 meganewton per meter square at an average temperature of 524 degrees Celsius. Low alloy steel with 1.25% chromium and 0.5% molybdenum has average yield strength of 207 meganewton per meter square at an average temperature of 563 degrees Celsius. High alloy steels. High alloy steel with 9% chromium, 1% molybdenum and vanadium has average yield strength of 414 meganewton per meter square at an average temperature of 649 degrees Celsius. Stainless steel. Stainless steel with 16% chromium, 12% nickel and 2% molybdenum has average yield strength of 207 meganewton per meter square at an average temperature of 760 degrees Celsius. Forms of steel required for various pressure parts. This slide describes the forms of steel used for fabrication of various special parts of water tube boiler. Drums and headers. Drums are used for storage and distribution of water and steam. Similarly, headers connect the tubes for circulation of water and steam. Drums and headers are fabricated by hot or cold rolling of the steel plates to give the desired shape and welded to form the pressure vessel. Superheater and reheater coils. Superheater and reheater coils are used for heating the saturated steam or its reheating and are fabricated from tubes which can withstand high temperature and attach to its headers. Economizer, screen and generating bank. Economizer, screen and generating banks are fabricated from tubes which can withstand saturated steam temperature and are connected between drum, headers or drum and header. Membrane or division wall panels. Membrane walls surround the boiler furnace to form its boundary to prevent the loss of heat. They prevent the leakage of flue gases and also reduce the refractory requirement. Tubes and strips are used to form this type of water walls which are connected between headers. Large bore downcomers. Downcomers are used to distribute water from steam drum to water drum or headers. They are made up from large diameter pipes and are not subjected to heat. All integral piping. Other internal pipes in boilers are fabricated from small bore tubes. Nozzles on headers and drums. Connections in the drum and headers for superheaters, reheaters, a temperator, desuperheater and economizer are steel forgings. Mountings. Mountings are made from cast steel, forged steel, stainless steel, gun metal, monal metal, bronze, etc. This completes the study of requirements for construction of boilers, specification of boiler plates, pipes and tubes and their sizes. Tube thickness as per their pressure ratings and forms of steel required for various special parts. This book has been written by me and covers all the topics as per Indian Maritime University syllabus. It explains key concepts using simple illustrations. The book also provides answers to all questions that have appeared in examinations conducted by Indian Maritime University. It will help students prepare effectively for exams and also support them in working safely with ships' boilers. I hope you enjoyed lecture. Feel free to share your feedback in the comment section. If you found this tutorial helpful, consider sharing it with your friends. Subscribe to the channel to stay updated with the upcoming tutorials. I'll be back soon with a new lecture. Thank you for watching till the end.